everyone. My name is Ish Dubey, and today I will be discussing the Math Kangaroo 2020 in USA, Level 7 and 8 problems. This competition was held on Thursday, March 19th, 2020. The first problem we will start off with is problem number 1. Problem number 1 says how many of the following four numbers, 2, 20, 202, and 2020 are prime? So we know that the characteristics of a prime number is that it cannot be divisible by any integer other than 1 and itself, and we also know that 2 is the only even prime number. Right off the bat, we can tell that these three numbers are even and they're not 2. But however, we know that 2 is even and 2 is 2, obviously. So 2 is the only prime number in that list. So therefore, we know that the answer is B because there's only one prime number in that list. Okay, so number 2 says, in which of the regular polygons below is the marked angle the largest? So in this question, you need to utilize the formula n minus 2 times 180. This formula is used to find how many total degrees are in a certain polygon, and n is equal to the number of vertices. So basically the way that you want to approach this question is just find the number of vertices in each triangle and plug it into this formula to find which polygon has the largest sum of angles, and then you would divide it by the number of vertices. So basically for A, it's a hexagon, so it has six vertices. So we would do 6 minus 2 times 180. So that's 4 times 180. Therefore, there's 720 degrees in that hexagon, and it's only saying the marked angle, which is only one of the vertices. So 720 times 1/6 equals 120. We keep repeating this process, such as B. B would be 5 minus 2 times 180, which is equal to 540. 540 times 1/5 is equal to 108. Since a pentagon's degree measure would be the same no matter what its size is, C would also be 108. And we all know that squares have 90-degree vertices, and triangles have 60-degree vertices. So this way, we just find which has the largest marked angle, and in this case, that would be A, which is 120. Okay, so number 3 says Miguel solves 6 Olympiad problems every day, and Lazaro solves 4 Olympiad problems every day. How many days does it take Lazaro to solve the same number of problems as Miguel solves in 4 days? So to approach this problem, we know that Miguel solves 6 every day, and Lazaro solves 4 every day. We know, so the question asks how many days it takes Lazaro to solve the same number of problems as Miguel in 4 days. So we know that Miguel is 6, so Miguel times 4 equals 6 times 4, So for Miguel equals 24 problems. So Lazaro would also inevitably have to solve 24 problems. So 24 divided by 6, no, sorry, divided by 4 equals 6. So therefore, we know that it would take Lazaro 6 days, which is C. Okay, so the next question is number 4. Number 4 says, which of these fractions has the largest value? This question is pretty straightforward. You just need to know, like the basic way to do this is that we just add each of these. Like for A, it would be 13 by 3. B, it would be 8 by 8. C, it would be 8 by 8. D, it would be 11 by 5. And E, it would be 3 by 11. So the main concept here is that if you want to find the largest number, you need to have the highest numerator and lowest denominator out of all of these. So doing that, we would know that A is the proper answer because it has the largest numerator and the smallest denominator. Number 5 says a large square is divided into smaller squares. In one of the squares, a diagonal is also drawn. What fraction of the square is shaded? So this question is relatively easy. We know that, okay, so assuming that this square has sides of 1 by 1, this is equal to 1/4. This is equal to 1/4 times half. And this is also equal to 1/4 times half. As this has only half of this entire unit block, and this entire unit block is a half by half, so that's 1/4. So we just multiply each of these out. So this is still 1/4, this is 1/8, and this is also 1/8. So we just add all these up to get 1/2, which is our answer, E. So number 6 says there are 4 teams in a soccer tournament. Each team plays every other team exactly once. In each match, the winner scores 3 points and the loser scores 0 points. In the case of a draw, both teams score 1 point. After all matches have been played, which of the following total number of points is it impossible for any team to have scored? So the important information that there's 4 teams. Each team plays every other team exactly once. The winner scores 3 points and the loser scores 0 points. And if it's a draw, both teams score 1 point. So for this question, we just have to try all the options. For 4, you would have to win, get a draw, then lose twice. For 5, you would have to get a win, 2 draws, and then a lose. For 6, you would need to get 2 wins and then 2 losses. For 7, you would have to get 2 wins and 1 draw and 1 loss. But no matter what, you can't get 8 points. No matter what you do. If you do 3, 3, 3, you get 9. If you do 3, 3, 1, you get 7. So no matter what you do, you can't get 8. So it says, is it impossible for any team to have scored? So the answer is E. Number 7 says the diagram shows a shape made of 36 identical small triangles. What is the smallest number of such triangles that could be added to the shape to turn it into a hexagon? So what we know is that this equals one triangle, and this equals two triangles. And we know that there's 6 of them on the hexagon, which is 6 times 2 equals 12. And there's 6 of these one triangles on the hexagon as well, so 6 times 1 equals 6. So 12 plus 6 equals 18, which is our answer D. Number 8 says, Congo wants to multiply 3 different numbers from the following list: -5, -3, -1, 2, 4, and 6. What is the smallest result Congo could obtain? So how you would approach this problem is that you know that the absolute value of the largest numbers would make the largest product. So in this case, that would be 5 times 4 times 6, which is 120. And luckily for us, 5 is also negative. And to get the smallest result, it has to be like the largest actual number. And then it has to have a negative sign in front of it. And -5, this 5 is actually negative. So it's -5 times 4 times 6 equals -120, which is B. Number 9 says, if John goes to school by bus and walks back, he travels for 3 hours. If he goes by bus both ways, he travels for 1 hour. How long does it take John if he walks both ways? So we know that bus plus walk equals 3 hours, and bus plus bus equals 1 hour. So we know that if he goes by bus both ways, it takes him 1 hour. So one-way bus would take only half an hour. Then we plug that into this equation, where we get 0.5 plus W equals 3 hours. So W equals 2.5 hours. And if he wants to walk both ways, then that's 2W equals 2 times 2.5. So 2W equals 5 hours. Therefore, we get our answer D. Okay, so number 10 says, a number is written in each cell of a 3x3 square. Unfortunately, the numbers are not visible because they are covered in ink. However, the sum of the numbers in each row and the sum of the numbers in each of the 2 columns are all known, as shown by the arrows on the diagram. What is the sum of the numbers in the 3rd column? So the key concept we need to know here is that the sum of all of these 3 numbers will equal the sum of all 3 of these 3. So 24 plus 26 plus 40 equals 27 plus 20 plus question mark. So we know that 90 equals 47 plus question mark. Therefore, question mark equals 43, which is B. Okay, so number 11 says the shortest path from A-town to C-town runs through B-town. The 2 signposts shown are set up along this path. What distance was written on the broken sign? So we can see that there's a difference between 5 and the first A-town sign and the second A-town sign, because 7 minus 2 equals 5. And there's also a difference of 5 here, as 9 minus 4 equals 5. So therefore we know that this will be 5, so 5 minus. Numbers 12 says, Anna wants to walk 5 kilometers on average each day in March. At bedtime on March 16th, she realized that she had walked 95 kilometers so far. What distance does she need to walk on average for the remaining days of the month to achieve her target? So we know that March has 31 days, so 31 times 5 equals 155, which is how many kilometers total she needs to walk in March. And she already walked 95 kilometers, so 155 minus 95 equals 60. And since there's 15 days left in March, since 31 minus 16 equals 15, 60 divided by 15 equals 4. So she would need to walk 4 kilometers for the remaining days of the month of March to achieve her target, which is C. Number 13 says, which of the following shows what you would see when the object in the diagram is viewed from above? So this question, all you have to do is draw from a bird's eye view, which would look something like this. The black represents the dark spots and the red represents these parts. Yeah, it would look something like this. And then looking at the options given, you could make the conclusion that the correct answer is B. Number 14 says every pupil in a class either swims or dances or does both. 3/5 of the class swim and 3/5 of the class dance. 5 pupils both swim and dance. How many pupils are in the class? For this question, all you have to do is multiply 3/5 by 3/5 to get 9 by 25. And the only important thing is the denominator, which is 25. You could subtract 5 from the top to actually follow the question, but that's irrelevant because the 5 pupils both swimming and dancing is kind of extra information. But the denominator is the only real thing that matters because it tells you how many total students there are in the class, which is 25. C. Number 15 says Sacha's garden has the shape shown. All the sides are either parallel or perpendicular to each other. Some of the dimensions are shown in the diagram. What is the perimeter of Sacha's garden? So we can definitively say that this entire side is equal to 3. And let's assume that we can take this entire part and move it up. So that would make us a diagram looking somewhat like this. Where this equals 4, this equals 4, this entire side length equals 3, this equals 3, this is 5, and this is 5. So we just add up all these numbers to get 24, which we can do quite easily. 3 plus 4 plus 5 multiplied by 2, which is 12 times 2, which equals 24. Therefore, our answer is C. Number 16 says Andrew buys 27 identical small cubes, each with 2 adjacent faces painted red. He then uses all of these cubes to build a large cube. What is the largest number of completely red faces of the large cube that he can make? So we know that Andrew has 27 identical small cubes. And these cubes have adjacent faces that are painted red. So, and since he has 27 of them, he can make a 3 by 3 by 3 cube, which would look something like okay, so number 16 says Andrew buys 27 identical small cubes, each with 2 adjacent faces painted red. He then uses all of these cubes to build a large cube. What is the largest number of completely red faces of the large cube that he can make? So the question says that he has 27 identical large cubes. Number 16 says, Andrew buys 27 identical small cubes, each with 2 adjacent faces painted red. He then uses all of these cubes to build a large cube. What is the largest number of completely red faces of the large cube that he can make? So we know that Andrew has 27 identical small cubes, which would look something like this. And they have 2 adjacent sides painted red. And he's trying to make a large cube. And with 27, he can make a 3 by 3 by 3. So this is how the large cube would look like. And since the cubes have 2 adjacent sides painted red, 2 faces would definitely be painted red. And you can also get 2 more by doing this. Since these also have adjacent sides over here, this entire face will also be completely painted red. And there's another face over here, which also has adjacent sides, therefore also being painted red. So that way we know that there are 4 faces that can be completely painted red, which is C. Number 17 says a large square consists of 4 identical rectangles and a small square. The area of the large square is 49 centimeters squared, and the length of the diagonal AB of one of the rectangles is 5 centimeters squared. Is 5 centimeters. Number 17 says a large square consists of 4 identical rectangles and a small square. The area of the large square is 49 centimeters squared, and the length of the diagonal AB of one of the rectangles is 5 centimeters. What is the area of the small square? So since the total area of the large square is 49, we can say that each side length equals 7. So, and we also know that each of these equals 5. And if you know any Pythagorean triplets, you can say that 3 squared plus 4 squared equals 5 squared. Therefore, we know that this side length is 4 and this side length is 3. So 4 minus 3 equals 1. And 1 squared equals 1, which is the area of this square in the center, which is A. Number 18 says, Werner's salary is 20% of his boss's salary. By what percentage should Werner's salary increase to become equal to his boss's salary? So we can first set up this equation. W, which is Werner, equals boss by 5. So, so we know that his boss's salary is 5 times as much, which would be 500%. But since he already has 100%, which is his own salary, which is minus 100%, equals 400%, which is our answer D. The next question is number 19. Number 19 says, Irene made a city with identical wooden cubes. One of the diagrams shows the view from above the city, and the other the view from one of the sides. However, it is not known from which side the side view was taken. What is the largest number of cubes that Irene could have used? So, to find the largest number of cubes she could have used, we know that this is 2, and there's 2 of these here, so this is 4, because 2 times 2 equals 4. And there's 4 here, so 4 and 4 is 8. And there's 1 here, and there's 2 here, so 2 times 1 equals 2. And there's 3 here, and 3 here, so 9. So we keep following the same pattern all the way around, which will make this 6, this 4, this 2, this 9, this 6, this 2, this 8, this 6, and finally this is 9, this is 1, this is 8, and this is 6. So we add each side. 4 plus 8 plus 2 plus 9 equals 23. 6 plus 4 plus 2 plus 9 equals 21. 6 plus 2 plus 8 plus 6 equals 22. And finally, 9 plus 1 plus 8 plus 6 equals 24. Therefore, the largest sum is 24, and that will be our answer, which is B. Okay, 20 says Aisha has a strip of paper with the numbers 1, 2, 3, 4, and 5 written in 5 cells as shown. She folds the strip so that the cells overlap, forming 5 layers. Which of the following configurations from top layer to bottom layer is it not possible to obtain? So for this question, I'm going to be using this strip of paper, which is the same as the one on the diagram, and I'll just be folding it accordingly to the answer choices. So first we have to have 3 on the top, then 5 below, then 4, then 2, then 1, which works. And then we have to have 3, then 4, then 5, then 1, then 2, which also works. Then C says 3, 2, 1, 4, wait a minute, 3, 2, 1, 4, 5. Which works. Then D says 3 on top, then 1 beneath it, then 2, then 4, then 5, which then again works. But then E will not work because, alright, let's just try it. 3, 4, 2, 1, 5. 5 will never be at the bottom because it's the edge, and the edges are always supposed to go, they always fit like somewhere in between, but in this case it doesn't work. So therefore the answer is E. Okay, so number 21 says 12 colored cubes are arranged in a row. There are 3 blue cubes, 2 yellow cubes, 3 red cubes, and 4 green cubes, but not in that order. There is a yellow cube at one end and a red cube at the other end. The red cubes are all touching. The green cubes are also all touching. The 10th cube from the left is blue. What color is the cube 6 from the left? So we'll start off by making 12 blanks. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And it says that there's a red at one end and a yellow at the other end. And it also says that all the reds are touching. So we add 2 more reds. And it also says that all the greens are touching. So we can place all the greens over here. Doesn't really matter where they go. And there's also 3 blues and another yellow. You could really just place them wherever. But no matter what combination you put, green will always be the cube 6 from the left, which is A. Number 22 says, Zaida took a square piece of paper and folded two of its sides to the diagonal, as shown, to obtain a quadrilateral. What is the size of the largest angle of the quadrilateral? So since we know that this is a square, each of these angles are 90 degrees, so 90 degrees times 4 is equal to a total of 360 degrees. And since she folded it into this odd figure, then we still know that this equals 90 degrees. And this will equal 45 degrees. So 90 plus 45 equals 135. And 360 minus 135 equals 225. And 225 is the sum of these two angles. So 225 divided by 2 equals 112.5, which is A. So 23 says, how many 4-digit numbers A are there such that half of the number A is divisible by 2, and a third of A is divisible by 3, and a fifth of A is divisible by 5? So to approach this question, all you do is 2 divided by half, which is 2 times 2, which is 4, and 3 divided by 1/3 equals 9, and 5 divided by 1/5 equals 25. So the LCM of 4, 9, and 25 equals 900. And since it asks for how many 4-digit numbers, meaning anywhere from 1,000 to 9999, we would start off with 900, but it's not a 4-digit number, so we'd have to start with 1,800 all the way to 9,900, and there's 10 multiples of 900 there, so the answer is D. Okay, so number 24 says, in the final of the dancing competition, each of the 3 members of the jury gives the 5 competitors 0 points, 1 point, 2 points, 3 points, or 4 points. No 2 competitors get the same mark from any individual judge. Adam knows all the sums of the marks and a few single marks as shown. How many points did Adam get from Judge 3? So I'm going to use black to represent 0, red to represent 1, blue to represent 2, green to represent 3, and pink to represent 4. So right off the bat, we know that a 3 is going to come over here because 2 plus 3 equals 5. And most of this problem is actually just making predictions. So you could go wrong, but you'll get it in 1 or 2 tries. So the next thing we know is that for Clara, there we can put a 1. And since we have a 1 here and a 0 here, then the next thing will be 2. And then for David, we can guess that this is 3. He gets a 0 down here. And since 3 plus 0 plus x equals 4, x will be 1. And then for Emil, to get 11, the only way you can get 11 with these numbers is 4 plus 4 plus 3. So we have to have 2 4s. We can put a 4 here and a 4 here and a 3 right here. Sorry. So I also color coded because we know how many of each number we have. So we have 3 3s, so we can't use any 3s. We have 2 4s, so we can use a 4. I'll put a 4 right here. And the only thing that's remaining is a 1, and this would be our third one. So Adam got 1 point from Judge 3, which is B. Okay, so number 25 says, Sania writes a positive integer on each edge of a square. She also writes at each vertex the product of the numbers on the 2 edges that meet at the vertex. The sum of the numbers at the vertices is 15. What is the sum of the numbers on the edges of the square? So we can just make a square that looks something like this. It's not the greatest square, but we'll go with it. Here will be A. Sorry. Here's B, here's A, here's D, and here's C. Here will be AB, AD, DC, and BC. So basically all we do is set up a polynomial, which would look something like this. Sorry. AB plus BC plus CD plus AD equals 15. And we just take out the common factor, which will be B A equals C plus D, A equals C equals 15. And we know that the only factors of 15 are 1 times 15 and 3 times 15. 3 times 5. And we know that you can't add any integer to get 1. So B times A plus C would equal 3 times 5. So we just know that 3 plus 8 equals, 3 plus 5 equals 8, which is C. Okay, number 26 says, Sophia has 52 identical isosceles right-angled triangles. She wants to make a square using some of them. How many different sized squares can she make? So we know that isosceles right-angled triangles look like this. My drawing's kind of bad, sorry. And using 2 of them, she can make a square. So 52 divided by 2 equals 26. And That means that she can make a 1 by 1, 2 by 2, 3 by 3, 4 by 4, 5 by 5, but not 6 by 6 because that's 36 and we only have a maximum of 26. So that completes the first part of the question. The second part would be that she can make a different size square, which would consist of 4 isosceles right angle triangles. You get the idea? So 52 divided by 4 equals 13. So that means she can make 1 times 1, 2 times 2, and 3 times 3, but not 4 times 4, because that would be 16, and we only have a cap of 13. So 4 times, 5 plus 3 equals 8, which is our answer. Okay, number 27 says, Cleo builds a pyramid with metal spheres. The square base consists of 4 by 4 spheres as shown in the figure. The floor consists of 3 by 3 spheres, 2 by 2 spheres, and a final sphere at the top. At each point of contact between two spheres, a blob of glue is placed. How many blobs of glue will Cleo place? So first of all, we make a chart for the rows. And the rows will have 2 by 2, 3 by 3, and 4 by 4. And we'll be using this formula, n in the n minus 1 times 2. And we're doing like the horizontal ones first because there's going to be two types of joints. One will be horizontal joints and the other will be vertical joints. Right now we're doing the horizontal ones. So we're just going to apply this formula into 2. So we get 2 times 1 times 2, which is 4. And for 3, we get 3 times 2 times 2, which is 12. And for 4, we get 24. So adding 4 plus 12 plus 24, we get 40. Now we'll be moving on to the vertical joints, or the columns. We'll be using the same formula for this, and we'll only be using 2 by 2 and 3 by 3. So that way we'll be getting, and a 1 by 1. So that way we'll be getting 4, 16, and 36. Now we know that the sum of these three is equal to 56. Therefore, 40 plus 56 equals 96, which is E. Okay, so number 28 says 4 children are in the 4 corners of a 10 by 25 meter pool. Their trainer is standing somewhere on one side of the pool. When he calls them, 3 children get out and walk as short a distance as possible around the pool to meet him. They walk 50 meters in total. What is the shortest distance the trainer needs to walk to get to the 4th child? So I'm just going to make a diagram. This is 10, this is 25, and we'll name all the children A, B, C, and D. So, assuming that the coach is somewhere here, then they'll need to walk a total of 10 plus 25, which is equal to 45, which is not sufficient because it's 45 is not equal to 50. But if the coach is standing somewhere here, then that will be 25 plus 25 plus 10, which is equal to 60. But 60, unfortunately, is not equal to 50. So the only solution that is possible is if the coach is standing somewhere here, and then they'll walk something of 10 plus 15 plus 25, which equals 50. So that way we know to get to the other, since this is 15, since that is 10 and that's 15, and this is also 10, to get to B, which is a fourth child, it's 10 plus 10, which is equal to 20, which is D. Number 29 says, Anne, Boris, and Carl ran a race. They started at the same time and their speeds were constant. When Anne finished, Boris had 15 meters to run, and Carl had 35 meters to run. When Boris finished, Carl had 22 meters to run. What is the distance they ran? So I'm just going to write down all the distances. 0, 15, 35. And this is Anne, this is Boris, and this is Carl. And then when Boris finished, there was 22 meters left, so 35 minus 22 equals 13. So we can say that for every 13 meters, Carl ran, Boris ran 2 more. And we also know that 35 minus 15 equals 20. So we do 20 divided by 2, which is 10. I'm dividing by 2 because he kept running 2 meters extra. So 10 times 13 equals 130. Then 130 plus 15 plus 20 equals 165, which is D. Okay, number 30 says, the statements below give clues to the identity of a 4-digit number. What is the last digit of the 4-digit number? So we can look at straight at the last step, and it says none of the digits are correct. So whenever we see a 7, 6, 4, or 2 in any of these, we can completely eliminate it. So, for example, from the first one, 4, 1, 3, 2, we can eliminate 4 and 2 as it's over here. Then from the next one, we can remove we can remove 2 and 6, leaving us with 9 and 8. And it only says that one digit is correct, so later on we'll have to choose one. 5, 0, 7, 9. It says 2 digits are correct, with one of them being in the right place and the other one in the wrong place. We can say that 9 is in the wrong place and is right, as we hypothesize that 9 is one of the correct ones. And since there's 7 here, and 5 can't go in the first place because 9's already there, the other one is going to be 0. So as of now, we have 9, 0, blank, blank. In the fourth step, it says one digit is correct, but in the wrong place. We remove 2, 7, and 4, only to leave us with 1, and it's in the wrong place. So If we refer back to the first step, it says two digits are correct and then in the wrong places. So we know that 3 cannot go here, and it can't go here either. So we'll have to say that 1 goes here and 3 goes there. So therefore, the last digit of the 4-digit number is 3, which is C.
Don't forget to subscribe and like. If you have any questions, you can email info@agoramatrical.org or comment below and we'll reply back. Maybe. And if you want to see practice things or anything about us, you can visit our website, which is basically the end of the email but without the info and the end. So bye!